And recording.
Okay, so now we switch rooms. It's very important to switch rooms when you move on to the third part of this problem. Okay, so we're given the graph of a signal, capital X3, in frequency domain once again, and we're asked to find it represented in time. So we notice that it's the composition of two different rectangular functions that are shifted over and centered at 4 and -4 with a width of 2. So we can rewrite capital X3 as a summation of rect of omega plus 4 over 2 and omega minus 4 over 2. Okay, and then by linearity of the inverse Fourier transform, all we need to do is take the inverse Fourier transform of this term and this term. Simple enough. And we can do that by taking in two pieces of information that we already know. Number one, that the inverse Fourier transform of rect of some omega over constant w is equal to w over 2 pi sinc wt over 2. And secondly, that the frequency shifting property of the inverse Fourier transform, that when you take the inverse Fourier transform of some function x of omega shifted over by omega naught, you just need to multiply the function in time by e to the j omega naught t. Okay, so putting those two things together, we get that x3 is equal to 1 over pi e to the -4jt sinc t plus 1 over pi e to the 4jt sinc t. And we're noticing once again that these two terms are complex conjugates, so we can represent them by doubling and multiplying by cosine of this angle, which gives us a final answer of 2 pi over sinc t cos 4t.